This conference will now be recorded.
Well, in last class we discussed about the data flow. Okay, so first we'll have the OLTP database. OLTP means online transaction process. Then ODS, which is operational data source, and then staging area or stage database. After that, we will have the data warehouse database. Next to the data warehouse database, we will have data marts. So this is the standard data flow in any project. Okay. So here I took the example of ATM machine or internet banking application, right? Okay. So whatever the domain it is, if it is telecom domain, in telecom we have prepaid, postpaid, broadband, right? TV, like that will have different products. Okay, so there also, if you want to purchase a new SIM or new mobile or new broadband connection, so you have to provide your details like first name, last name, email ID, phone number, address, like that. So whatever details you have provided, the front end application, they will be filling the form and they will click on submit button. Okay, as soon as they click on submit button, first a record will be inserted inside the OLTP database tables. Okay, we'll have the customer table, prepaid customer table, postpaid customer table, broadband customer table, TV customer table, like that. There also will have the OLTP database, and there also will have the ODS database. And from there we extract, transform, and load the data into the staging. We know here we have the staging database to do the data validation. If there are any incorrect records coming from the source, to correct those records or to fix those error records, we have staging database here. And then next to the staging database, we have the data warehouse database. Inside the data warehouse database, there we maintain the historical data. So if the business is running from last 10 years or 20 years, data warehouse will have 10 or 20 years of data. That is the reason. Instead of directly generating the report on top of the data warehouse, we load the data into the data marts. Different data mart will be there. So inside the data mart, we load the data whatever is required to generate a report. Okay, so if the business people they are expecting to have last 3 years of data in the report, then from the data warehouse to this reporting database we load only last 3 years of data. Okay, so like that the data flow will happen between source to the destination final to the data marts. Okay, so as I mentioned, like this is 100% interview question. In every interview, they'll ask to explain your current project or the data flow and all. So you have to explain the same thing. In my project, the source databases are like OLTP and ODS. These are created in the Oracle database type. Database type is Oracle. Inside the Oracle, as I shown you in the last class, we have XE database, right? By default, XE create. So like that here inside the Oracle database type, they have developed this OLTP, ODS, staging, data warehouse, data marts, everything will be there in the Oracle database type. It is not mandatory that all the databases should be in Oracle database type. Okay, so it can be a SQL server. You can have like OLTP and ODS in a Oracle data warehouse. Can be another database type like SQL server. SQL server is another database type. Okay, so in the same way, we have DB2, another database type like Oracle. We have, Netezza. We have Yellow Brick. We have Snowflake. All these are the database types like Oracle. Okay, so it can be any database. It is not mandatory that it should have everything in a single database. No, but in interview, if they ask, tell me all these databases under which database type they have developed. You can say Oracle. Inside the Oracle database type only, we have this OLTP, ODS, and then staging, data warehouse, data marts, like that. All these databases we have under Oracle database type. Okay, so like that the standard data flow. Next, here inside the data warehouse, if you see, we have DF, right? So D means dimension table, F means fact table. Okay. So inside the data warehouse, we'll have the dimension tables and fact tables. Okay. So what is meant by dimension table and what is fact table, that we will discuss. Okay, so dimension table, or in short form we also call it as dim table. Okay, so dim table or dimension table, which will have inside the data warehouse, which contains the primary key and master data. Okay, so this is the definition. In data warehouse, we do not have any practical to do. Okay, in the last class also, I have not given any practical to do anything in your system, right? Okay, so all these are the theory concepts. We just have to know the definitions. Okay, so in interview also they will ask, from data warehouse only theory. So here we do not have any practical to do. So once we start Informatica, then every day I will give 4 5 scenarios to do the practice. But here in today's session also, we do not have anything to do. So we just have to know the definitions. That's it. Okay. So what is dimension table? Dimension table contains the primary key and master data. Also, we called it as a non-measurable data. Next, what is primary key? Okay, so primary key is one of the constraints which are available in SQL. Okay, suppose let's say here there is a table. For example, we have a employee table. Okay, so in employee table we have the column names like employee number, employee name, salary, like this we have. Now, so these primary key constraints can be created on top of columns in a table. Let's say on employee number, we have created the primary constraint. Okay, so on employee number column, we have created the primary key constraint. So in that scenario, this employee number column will allow to insert only distinct values. Okay, I will write the rules of primary key. This is also very important constraint. In real time, every table will have this primary key constraint. Okay, so on top of a column, these constraints will be created in a table. If there is a primary key constraint created on a column in a table, that column will not allow to insert duplicate values. Okay, that is first point. And then, so if there is a primary key constraint on any column, it will not allow to insert null values. It will not allow to insert the null values. Next, if there is a primary key constraint on a column, okay, so we have to insert only unique values. It will allow to insert only distinct or unique values. Okay, that is third point. Next, primary key can be created on numeric or non-numeric columns in a table. What it means? So the first point, these are the 4 points which we have to remember whenever we talk about the primary key. Okay, so whenever we talk about the primary key, you should have to remember these 4 points. These are very, very important. The first point, it will not allow to insert the duplicate values. What it means? Now, suppose let's say I have inserted the first record like this. One employee name A and salary 100. Now again, if I try to insert one more 10, so 10 already there here, and what if I insert 10 here? Will it allow to insert? Is this the duplicate value or not? Will it allow to insert the one more 10 here again? If I try to insert 10,
No,
yes or
sir.
no? No, it will not allow because this is a duplicate value, right? So 10 already there. Again, if you try to insert one more 10, this we call it as a duplicate value. If there is a primary key constraint, then it will not allow to insert the duplicate values. Okay, so if there is a primary key constraint, then it will not allow to insert the duplicate values. Got it? Okay, that is first point. Second point, it will not allow to insert the null values. Null means, suppose while inserting a row in this table. Now let's say I am inserting. So to insert a row in the table, insert into EMP values, we have to write a query like this, right? I have shown you in the first class. So for the first column, null means empty, null, and then B, and then 200. So can we insert like this? Null means there is no value, even though if you don't write here. So simply if you put comma B 200, that means we are not passing any value to the employee number here. So which means it will insert the null values. Null means blank, empty. So can we insert a null value inside the primary key column like this? Will it allow to execute this statement if there is a primary key on a column in a table? Yes or no? Will it allow to insert the null value? Means no, it will not allow to
No.
insert the null value. There
No.
should be some value here inside the employee number column. Okay, so some value should be there, then only it will allow. Okay, so primary key column will not allow to insert the null values. Okay, that is second point. Okay, and what about third point? Okay, so third point is it will allow to only distinct value, like always it should be something like this 20, 30, 40, 50. So like that we can have the distinct values, right? Do we have the duplicate values here? No, like this it should be unique values. Always it should be their unique values or distinct values. So if there is a primary key constraint on a column, always it should allow to insert the unique values. There should not be any duplicate values. Okay, that is third point. Next, fourth point. Primary key either numeric or non-numeric columns. What is the difference between numeric and non-numeric columns? Any idea what is non-numeric column?
Character column.
Yes. Yes, correct. Character type of columns. Now here employee number is a numeric column. While creating the table for this employee number column, we give the data type as number. That is a numeric column. How about employee name? For employee name, while creating the table, we give the data type as varchar2. So varchar means that column will allow to insert the character type of data. This is character, right? So this primary key constraint, it is not mandatory that we should have to create on a numeric column. No. So you can have the primary key constraint on numeric column, or you can also have the primary key constraint on non-numeric column. Employee name is a non-numeric. So we can create a primary key constraint on non-numeric column also. So if you create a primary key constraint on non-numeric column, then we can create like this, and this column will allow to insert the duplicate value and will not allow to insert the null values, right? That's all about primary key. Still, if you want to know more, so you can refer the SQL recordings. I have also shared the SQL recordings, right? There are 5 recordings. Okay, I request everyone to go through the SQL recordings once. Every day one recording you can go through it. Okay, so first today first recording, tomorrow second recording, like that. There I already explained all these basics like SQL basics. Still parallelly I am explaining here. So to the I mean like to know more about the SQL basics, you just refer those SQL recordings. There I explained some more constraint, like we have foreign key constraint, check constraint, default constraint, like that we have other types of constraints are there. Okay, now
Yeah.
and
Is
also
it possible?
yes.
Is it possible to give letter alphabet in employee number column? Primary
No,
key.
since it's a numeric, yeah, it's a numeric column. While creating a table, you have given the data type as numeric number. So this
Oh,
column will not allow to insert the character of data. Whereas varchar2 data type will allow to insert number and as well as a character. That num varchar2 will allow to insert the numeric as well as a character type of data. Okay,
SQL.
so please watch the SQL first class recording. There I explained in detail. We have another other data types like char, varchar also we have. Okay, so I explained the difference between what is the char, varchar, and varchar two data. So please go through it. You will understand a better way the difference between character and numeric. So numeric will allow to insert the number or not.
Hello, sir. My question
Yeah.
is,
Yes. Any other?
if I place the primary key on employee name, if some employee is having the same name as like some employee's name is Raju, so again the same name will be there.
Yes.
Then it will not be allowed to place that name, no. So duplicate will not be allowed.
Exactly.
In what time? What on
Yeah.
that time? What?
So we should not create a primary key on employee number. I'm just example here. We can create a primary key on numeric or non-numeric. Okay, so if in some case like we have a product name, so product name in a product table for each and every product there will be a unique product name, right? In that case, so if you want to create a primary key on product name, you can create a primary key on product name. But here in employee table, we cannot create a primary key on employee name. Okay, I'm just giving the example like we can create a primary key on non-numeric column also. If you create a primary key on non-numeric column, definitely that column will to insert the duplicate values. The same name you cannot insert multiple times. So in that case, you should not create a primary key on employee name. Instead of creating the primary key on employee name, you have to create a primary key on employee number. So now let's say 20A200. So will it allow to insert 20A200? Is it valid? No, tell me. Can we insert like this? Now, the same name we have for two employees, but employee ID is unique. So his first employee ID is 10, second employee name same, but his employee ID is 20. So if you have same names, then we should not create a primary key on employee name. We should have to create a primary key on employee number.
Okay, sir.
Got it? Like that. Yeah. So again, once we start Informatica in Informatica class, that time for a few of our scenarios, we will be creating the primary key. That time I will show you practically how we can create a primary key on a column in a table. So I'll write a query that time and I will show you. Okay, for now, just understand primary key means it will not allow to insert the two values. It will not allow to insert the value. There should be only distinct values. We can create a primary key or numeric or non-numeric columns, but there should be only one. So that also we will include here. Okay, so there should be only one primary key in a table. Okay, there should be only one primary key in a table. You cannot create multiple primary keys. So here you cannot create like that. There should not be two primary keys in a table. Okay, so we should have only one primary key. This is invalid. You cannot create like this. This is invalid. So there should be only one primary key in a table. Okay, so if there is a requirement to create a primary key on two columns, then what do we have to do? As I told you, there should be only one primary key column in a table. We should not have more than one. So if we have a requirement, now I want to create a primary key on two columns, then we should not call that as a primary key. We should call that as a composite key. Composite key. So composite key can be created on multiple columns in a table. Okay, so that we call it as a composite key. Composite key can be created on multiple columns in a table, but primary key there should be only one. Okay, these are 5 points which we have to remember for primary key, and they are very important because in real time every table you will see the primary key. Next, now here we were discussing about dimension table. Dimension table contains the primary key and master data. We also called it as a non-measurable data. Show you the dimension and fact model. So we have a dimension and fact model. Yeah. So you can see here we have dimension model and fact model. Okay, and one more thing I just wanted to tell you here in GoToMeeting, I am not sure whether you are able to see the full screen or not. Okay, so in your GoToMeeting top, you will see participants, right? So you can drag that window to up. So you will get the option to drag, place the cursor below to the participants and drag that window to up. That is one thing to get the full screen. And also right side, you will see two arrows pointing to each other in your GoToMeeting, whatever the screen you are seeing on top right side corner. Two arrows pointing to each other. You just have to click on the two arrows which are to each other. Then so you will get the full screen. Got it? Still, if you are not able to see the full screen, whatever you're seeing, you just take the pic and send me in WhatsApp. I'll just suggest you like how you can get the full screen. Okay, fine. So here we have a dimension table. You can see this is the item dimension table. In item dimension table, the first column we have primary key column, right? As I told you, dimension contains the primary key and all the other columns are non-measurable columns or master data columns. Item name which contains the character type of data. So we cannot measure the characters. We can measure only numbers. Okay. So all the columns apart from the primary key column, all the other columns, whatever we have in a dimension, those are non-measurable columns. We just have to know the definition. In interview, they ask, tell me what is dimension means. Dimension contains the primary key and master data, which also called it as a non-measurable data. For example, if there is an item dimension, in item dimension, item key as a primary key column, other columns are like item name, which is a character type of data we cannot measure. Brand also it's a character type of data we cannot measure. Sold by, again this also sold by which contains the character type of data. We do not have numbers in sold by, right? Category, again it contains the character type of data we cannot measure. Okay, so all these are the varchar2 data type columns. Those are the non-measurable columns. In the same way, branch dimension, if you see here, we have the first column is a primary key. Apart from the other columns are non-measurable columns like branch name, owner. These are the non-measurable column. In the same way, we have time dimension. We have time ID, which is a primary key column. This day, month, quarter, year, all these are also we can call it as a non-measurable columns. At the same time, here we have location dimension. Location ID is the primary key column. Here we have a name, which is a character type of data. State, character type of data. Pin code, character type of data. So like that, remember, dimension contains the primary key and the other data, which is called it as non-measurable data. That is the definition dimension table. Next, fact table. Fact table contains primary keys of the dimensions. Okay, so fact table contains primary keys of the dimensions and measurable data, right? So it contains the primary keys of the dimension. Here you can see we have a fact table, which is sales fact we have. In this primary keys of the dimension, item key is a primary key from the item table. Time ID is a primary key from the time dimension table. Branch ID is a primary key from the branch table. In the same way, location ID is the primary key in the location table. So here, item key is a primary item dimension, whereas the same ID, if you have in a fact, this we call it as a foreign key. FK means foreign key. This is a foreign key because this item key already available in the item dimension as a primary key. The same column, if you have in a fact, then such column we call it as a foreign key column. In the same way, time ID is a primary key in the time dimension. There it is a primary key. So when we have the same column in the fact, then we call it as a foreign key column. This terminology and all very important. So again, you watch this recording, try to get the notes and try to learn terminology or words, okay, twice or thrice like that. And then we have a branch ID, which is a primary key column in a branch dimension, whereas the same ID we have in a fact table, we call it as a foreign key. Like that, we'll have all the dimension keys, primary keys in a fact table. We called it as a foreign keys. And then apart from the dimension, primary keys of the dimensions, we have a measurable data or measurable columns. Quantity sold, quantity is a number, right? So we have 2 quantity, 10 quantity, like that, 15 quantity. So that is a number, we can measure the quantity. Amount also we can measure, like 10, 20, 30, 500, 1000, 2000, like that. We can measure the amount, that also numbers. Average sales, so how much percent of sales happened, like 10%, 20%, that also we can measure, right? So all these are the measurable columns. Okay, so like that, dimension contains the primary key and all the other columns are non-measurable columns, whereas the fact contains primary keys of the dimensions and measurable columns. Okay, so we just have to know the definition, and we are not going to decide as Informatica developer. It is not our responsibility to decide which column should be there in a dimension and which column should be there in a fact. We just have to know the definition. So who will decide what is the primary key column in a dimension, and who will decide what are the non-measurable columns in a dimension? Means there will be a separate team, architect team will be there, architects or data modelers, right? So they will design the data model. This is called data model or a schema, right? So these and all architects, they will design these schemas and the data models. They will decide what column should be there in a dimension and what column should be there in a fact. Okay, so we just have to know the definition. So what is dimension, what is fact? That's it. Next, types of schemas. So in data warehouse, we have 2 types of schemas. One is star schema, the second one is snowflake schema model. Okay, this is also very important interview question. So in most of the interviews, they will ask, tell me what is the difference between star schema and snow schema in data warehouse. So star schema means just now whatever we've seen here, this is called star schema. Why we call this as a star schema? Remember, in a star schema, fact table should have connected with all the dimensions. In a schema, if fact table is connected with all the dimensions, then we can call it as a star schema model. Connector means all the dimension keys should present inside the fact. Now here we have 4 dimensions and 1 fact, right? So do we have all the 4 dimension keys inside the fact or not? Do we have all the 4 dimension keys inside the fact?
Yes.
Yeah, yes.
Right? So yes, since all the 4 dimension keys present inside the fact, so that's the reason we called it as a star schema model. If at least one of the keys, suppose let's say branch ID does not exist here, we have in our schema there are total 4 dimensions. Out of 4 dimensions, only 3 dimensions primary keys present inside the fact. In such case, can we call this schema as a star schema? In a schema, if there are total 4 dimensions, out of 4 dimensions, only 3 dimension keys present inside the fact and 1 dimension key does not exist. For example, here we have a branch ID. That branch ID does not exist inside the fact. In such scenario, can we call this as a star schema model?
No.
No, right? Okay, so we cannot call, because star schema means it should have all the dimension keys, then only we can call it as a star schema model. Okay, that is the definition of the star schema. Remember. Next, coming to the snowflake. What is meant by snowflake schema? So here we have a snowflake. This is called snowflake schema model. Okay, so here also we just have to know the definition. In snowflake schema model, if you observe here, we have one fact, which is fact underscore sales, right? And left side to this fact, we have total 4 dimensions. Right side to this fact, we have 5 dimension tables. Total 9 dimensions are there in this schema. So you have 9 dimensions here. Do we have all the 9 dimension keys inside this fact? How many dimension keys are there in this fact?
Only 4.
4.
Any other answer? How
4.
many dimension keys are present inside this fact?
4.
4 is
4,
the
sir.
wrong answer.
3, sir.
Hello, 1. 1.
1 is the wrong answer.
3.
How many are there? 3. Yes, 3 is the right answer. Okay, so you can see this fact contains 3 dimension keys. The first one is date ID. Here from the date we have a date ID. It is connected to the date dimension. And also this fact is connected to the store dimension. We have a store ID. And in the same way, this fact is connected to the product dimension. We have a product ID. And unit source, that is a measurable column, right? So this is not any key in any of the dimension. We have, these are the 3 IDs or keys. We call it as 3 IDs or keys. So date ID, store ID, product ID. This fact is connected with how many dimension? Date dimension, store dimension. You can see the links here. Product dimension connected with only 3 of dimension. Even though here we have total 9 dimensions, this fact doesn't have all the 9 dimensions. This fact contains only few of the dimension keys, which are only 3 of the dimension keys we have in this fact table, right? So in a snowflake schema, fact should not connect with all the dimensions. So if fact is connected with all the dimensions, then we can call it as a star schema model. Connected means all the dimension keys should present inside the fact. Here we have total 9 dimensions. Even though we have 9 dimensions here, this fact contains only 3 of the dimension keys. This is connected with only 3 of the dimensions, not all the dimensions, only 3. And here we have a dimension link. We have a store dimension and geography dimension. This geography ID present in the store dimension, right? So whether in star schema model, do we have any relation between dimension to dimension? No. All the dimensions are connected to the fact, but there is no link between dimension to dimension. Whereas in snowflake, so fact should have connected with only few of the dimension, and also there should be relation or there should be a link between dimension to the dimension. Then we can call it as a snowflake schema. Okay, so remember the definition. You have to note down these definitions in your notes, and before the interview, definitely you have to go through all these things, because this is also one of the important interview questions. They will ask just difference. Tell me what is the difference between star schema and snowflake schema. So in star schema, fact should have connected with all the dimensions, which means all the dimension keys should present in the fact. Then we can call it as a star schema model. In snowflake, fact should not connect with all the dimension. It should have only few of the dimension keys, and also will have a relation between dimension to dimension in a snowflake schema. That's the difference between star and snowflake schemas. That's it. Okay. Next we have types of dimensions. How many types of dimensions are there? So in data warehouse, we have 4 types of dimensions. One is conform dimension, or we also call it as a reusable dimension. And then junk dimension, degenerated dimension, and slowly changing dimension. These are the 4 types of dimensions we have in data warehouse. Again, in slowly changing dimension, we have a slowly changing dimension type 1, 2, type 3 as SCD. SCD means slowly changing dimension. SCD type 1, SCD type 2, SCD type 3. Like I have 3 types in SCD. SCD type 1 dimension contains the latest data or current data, whereas the SCD type 2 contains the historical data. Type 3 contains the partial history, right? So like that, we have different types of dimensions we have in SQL. This is also another important interview question. They will ask me how many types of dimensions are there, or they also ask me how many types of acts are there. So types of dimensions, we have 4 types: conform dimension, junk dimension, degenerated dimension, slowly changing dimension. Again, in SCD we have three types: SCD type 1, type 2, type 3. Type 1 contains the latest data or current data. Type 2 contains the historical data. Type 3 contains the partial history. Okay, now we'll discuss the definition of each and every type of dimension. First, let's start with conform dimension. What is conform dimension? Okay, so conform dimension means, let's say there is a employee table. Okay, we have two projects, right? Let's say this is a G project, General Electrics. So there is the account called GE, or we'll take Amazon. Amazon project we have. So there is a table called employee, and this employee table contains all the Amazon employees information. Okay, so on the other hand, we have Flipkart. Okay, so Flipkart here also, I mean, like in our company there are two projects. One is Amazon project, let's say the other one is Flipkart project. So here also we have a requirement that we have to create a employee table. Okay, there are two different projects in a company. Okay, so in one project already created a employee table. There we have Amazon employees information. Okay, fine. Now you are working in Flipkart also. Okay, there also you have to create a employee table. Okay, since we have already created the employee table here, can we copy paste this employee table to the Flipkart? Can we have the same table in a Flipkart also with the same table data? Is it
Yes,
valid?
sir.
Is it valid? Can we
Yes.
copy paste the same table in the Flipkart employee?
No.
No. Why?
Primary key.
Why not? Okay, as I told you, this employee contains, right? No, not the primary key. This employee contains Amazon employees information, right? So can you have the same employees in Flipkart also? Whoever are working in Amazon, they will also work in Flipkart parallelly. Is it possible?
No.
No, right? So yeah, how come we have the Flipkart Amazon employees information in the Flipkart table? It is not possible. We cannot copy that one, right? So this Flipkart will have the Flipkart employees information. How you will copy the Amazon employees information into the Flipkart? That is not possible, right? Okay, so we cannot do like that. Clear? So like that, so this is not possible. So we cannot call this as a, suppose if this is a dimension, we cannot call this as a conformed, we cannot reuse. Okay, so conformed dimension means, suppose let's say here we have a calendar dimension. Here we have a date, day, year, such type of information we have, day, year, month, something like date, month. Okay, day, year, something like this. We have the columns. So this calendar information in Amazon, whatever the date here we have, Flipkart also will have the same day. Today, if today is Friday, same in Flipkart also. There are for those employees also today Friday. Amazon employees also today Friday. Their employees also, another project employees also today is Friday, right? So like that, if the same table structure, if the same table data, if we can use in multiple accounts or multiple projects or in multiple teams, then we can call it as a conformed dimension. I repeat, employee is not a conformed dimension because each and every project will have their own employees information. We cannot copy the employee table data from one project to another project, whereas this calendar information like days or month or year, such type of information if you have in a dimension, so the days or month or year will be same across multiple projects. So if you copy or if you reuse the same project, same table into the multiple projects, then we can call it as form dimension. Okay, so I repeat, confirm dimension means if any dimension table can be reused across multiple projects, then such type of dimension we call it as a confirm dimension. Example, we have calendar dimension. Calendar data remains same across multiple projects. So such type of dimension we call it as a confirm dimension. We just have to know the definition, that's it. Next, junk dimension. What is junk dimension? Junk dimension means if any dimension data keep on updating every second or every minute, if you are getting the latest updates, then such type of dimension we call it as a junk dimension. For example, we have a stock market information, right? So if you are maintaining the stock market information in any dimension, we know stock market information every second or every minute will get the latest updates, right? So such type of data, if you are maintaining in any dimension, then that is called junk dimension. Okay, so I repeat, junk dimension means if any dimension data keep on updating every second or every minute, if you are getting the latest updates, then such type of dimension we called it as a like a junk dimension. We just have to know the definition, but in real time and all, you will never see this junk dimension and all. Okay, so just for interview point of view, we just have to know the definition. In interview also, if they ask, have you ever used this junk dimension or confound dimension or this degenerated, you can say no, I have never used in my project. I just know the definitions, that's it. Okay, next, what is degenerated dimension? Degenerated dimension means, suppose here we have, there is a schema. In this schema, we have a pin code column. The last column which we have here in a location is pin code. Okay, so pin code we have in a dimension. Okay, sometimes we want to store this pin code in fact also, which is a non-measurable column. Pin code is a non-measurable column because in some countries we have a characters as well as the numbers. Okay, so we already have that pin code in a location dimension. The same pin code if you want to store in a fact, right? So pin code we have already in a dimension, and we want to store the pin code column in a fact also. Now whichever the dimension is having the pin code, and that dimension we called it as a degenerated dimension. I repeat, degenerated dimension means if any dimension is sharing its column with a fact, then such type of dimension we called it as degenerated dimension. Okay, so this pin code, if we store in a fact also, this dimension we call it as a degenerated dimension. I repeat the definition. Degenerated dimension means if any dimension column, or we also call it as an attribute, if any dimension column or an attribute sharing with the fact, then such type of dimension we call it as a degenerated dimension. Definitions are very important, you have to remember. Okay, for example, if there is a location dimension, in that if there is a pin code column, the same pin code column, if you are going to store inside the fact table, then whichever the dimension has shared its column with the fact, then such type of dimension we call it as a degenerated dimension. Got it? That's all about degenerated dimension. Next, we have slowly changing dimension. In slowly changing dimension, we have type 1, type 2, type 3. Out of these three, type 1 and type 2, which I have highlighted in a box, okay, so they are very important. So 100% in real time, we create the Informatica mapping for this SCD type 1 and SCD type 2. Okay, in the last class, I have explained here, right? If you see here, this SCD T2 means type 2. So between staging area to data warehouse, here we create SCD type 2 mapping because here we maintain cycle data in the data warehouse. So whatever the mapping we create between staging area to data warehouse, we call it. Okay, in Informatica, practically we will create a mapping for this SCD type 2. There I will show you. In the same way, SCD type 1, here we create between data warehouse and the data marts. Okay, so here we'll create SCD type 1. So we'll see what is SCD type 1 practically in the Informatica class. Right, but SCD type 3 very rare or we never create. That also we'll see what is meant by partial history, how to maintain the partial history. So these are the three types of SCD have. So that's all about types of dimensions. Next, coming to the types of facts. So facts, we have four types. One is additive fact, semi-additive fact, non-additive fact, and factless fact. So these also we just have to know the definitions. Okay, so no one will ask in detail about these facts and all. So they'll just ask for the definitions from data warehouse. We just have to know the definition. That's it. What are the, how many types of facts are there means like four types. Okay, what is additive fact? Additive fact means which contains all the dimension measurable data. A fact which contains all the dimension keys and measurable data, such fact we called it as the additive fact. So here the fact which we have in a star schema, so this fact we called it as the additive fact because we know this fact contains all the dimension keys and measurable data. That's the reason we call this as additive fact. What is meant by additive fact? Additive fact means the fact which contains all the dimension keys. Then such fact we call it as additive fact. Now here we have four dimensions. In this fact we have all the four dimension keys, right, and measurable data. So such fact we called it as additive fact. Next, what is semi-additive fact? Semi-additive fact means the fact which we have in a select schema. Then this fact we call it as a semi-additive fact. So as per the definition, semi-additive fact means it contains few of the dimension keys, not all, only few of the dimension keys and measurable data. Okay, so this fact contains whatever fact we have here in a snowflake schema, only few of the dimension keys, not all the dimension, and measurable columns like units told is a measurable column, right? So like that, if any fact contains only few of the dimension keys and measurable columns or data if you have, then such type of fact we call it as a semi-additive fact. Next thing, what is next? We have non-additive fact. What is meant by non-additive fact? Non-additive fact means only measurable data, no primary keys of the dimensions. Okay, so non-additive fact means, let's say we have a dimension and one dimension, and this is dimension, and this is a fact table. Okay, so here as per the definition, only measurable data, no primary keys of the dimension. No primary keys means this fact, is it connected with the fact, is it connected with the dimension or not? So if no primary keys means, do we have any link between fact to dimension? So like that we have. So in this scenario, so no primary keys of the dimensions, right? Measurable data, no primary keys of the dimension means, is this fact connected with any of the dimension?
No.
No, right? So this fact should not connect with any of the dimension. There should not be any link. If there is a link, then this dimension key will be there in the fact. Okay, but currently we do not have any link here. Okay, so that is the reason we call it as a non-additive fact. So if the fact is not connected with any of the dimension, if the fact is not connected with any of the dimension, this fact non-additive fact. So that's next to factless fact. Factless fact means only primary keys and no measurable data. Okay, it should connect with all the dimensions, right? So it should connect with all the dimensions, and it should not have the measurable data. So for example, here we have it should have all these keys: item key, time ID, branch ID, location ID, but it should not have these columns. So like quantity, amount, average, this should not be there. Okay, I repeat, factless fact means only primary dimensions, means it should have connected with all the dimensions, but it should not have measurable data. Then such type of fact we call it as a factless fact. Clear? Any questions till now? Okay, fine.
Can you please explain me again factless fact?
Next, finally, what is it? Can you repeat again?
Explain me again factless fact.
Factless fact means
Yeah, can you please explain
yes,
again
factless.
practice?
Yeah. I'll open screenshot. Okay, so factless fact, which means now this is factless fact, right? So this fact, if you see the definition, only price of the dimensions. Do we have only price of the dimension here or not? Or do we have any measurable columns here? No, it should contain only primary keys of the dimensions, and there should not be any measurable columns. If any fact contains only keys, primary keys of the dimensions, okay, and there is no measurable data, then such type of fact we call it as a, this fact we call it as a factless fact, right? In an interview they may ask the definition, tell me what is factless fact, then you have to say if any fact contains only primary keys of and no measurable data, then such type of fact we call it as a fact, such fact we call it as a factless fact. Got it now? What factless fact? Right, this is called factless fact. It should have only keys. Now item key, time ID, brand ID, location ID, like that we have all the dimension primary key columns and there is no measurable data. That's the reason we called it as a factless fact. Like, what is non-additive fact? So before that we discussed about this non-additive fact, right? What non-additive fact? Only measurable data, no primes of the dimensions, which means it should be like this. So this fact, now this is also fact. Remove this. This is also fact table. Is this fact connected with any of the dimensions now? Do we have any dimension keys in this fact? This is also fact. Is this connected with any of the dimension?
No.
Is this fact connected with any of the dimension? Yes or no?
No.
No.
Then this fact we call it as a what we call non-additive. This one, yeah, non-additive fact. It contains only measurable data. So if you see, we have only measurable columns here. Okay, and no primary keys of the dimension. No primary keys. We don't have the primary key. So such type, if there is any fact like this, if it is not connected with any of the dimension and it contains only measurable column, no primary keys, then this fact we call it as a non-additive fact. Got it? So like that you have to remember the definitions. Got it? Finally we have here data mart and the data warehouse. So here already discussed about the data warehouse and the data mart. Data warehouse contains the whole history from day one to till late, years of historical data we will have. So such type of history we called as a enterprise level history. So what is the difference between data mart and data warehouse? Data warehouse contains the enterprise level history. Enterprise means whole organization history. Suppose let's say in an organization if there are 5 departments, all the 5 department history will be there in the data warehouse from day 1 to till date. Whereas the data mart means department level or report level history. Okay, specific department, not all the 5 departments history, only one department history will be there. Okay, or the specific report. So if the report wants to see only last or 3 years of data, such type of limited history will be there inside the data marts. Okay, so that's the difference between data warehouse and data marts. So data warehouse contains the historical data which is at enterprise level, and data mart also contains the historical data which is at department level history will be there. That's it. So that's all about this data warehouse. So with this, we have done with the data warehouse. So only theoretical part here, we do not have anything to do practical. So we just have to know what is ODS, this data flow, and then what is dimension fact table, types of schemas, types of dimensions, types of facts. Only these things we should have to know. That's all about the data warehouse. Any questions? Okay, so that's all for the day. We'll stop here today and then we'll continue tomorrow. Tomorrow also we have class at same time. So tomorrow we will start Informatica, right? So tomorrow first initial 5-10 minutes we'll have the introduction about the Informatica. Then practically I will show you the scenario, how we'll create a mapping in Informatica, how we can use the Informatica tool. So tomorrow we will start with Informatica. Fine, that's all for the day. Thank you.
Do we have
We'll
classes for Sunday?
Tomorrow we have class, but Sunday we do not have. Sunday, India and Sunday we do not have class. But okay, for US student who joined from USA, so for you, like we do not have class on Saturday, and we have the class on Sunday evening for US students. Got it?
Okay.
Okay. So tomorrow we have class, and day after tomorrow we do not have. Okay, that's it. That's all for the day. Thank you.
Thank you, sir.
Thank you.
Thanks.